Yeah, good evening, my people. If you have been able to do the coding yourself, congratulations, we're making progress. So I haven't concluded the video on coding. Let us quickly run our analysis. Recall that the questionnaire that we use for our coding, the topic is the effect of motivation on employee performance. And we look at two motivational elements, increment in salary and bonus. So meaning we're looking at the effect of increment in salary and bonus on employee performance. So let us quickly come up with 3 research questions, 3 research objectives, 3 research hypotheses. So let's say 3. The first one, we're looking at the association between increment in salary and employee performance. The second one, we're looking at the effect that exists between bonus and increment in salary. The third one, we're looking at the combined effect of both increment in salary and bonus. So that is talking about the motivation element. So we're looking at the effect of the motivational element, the combined effect of the motivational element on employee performance. So let's come up with 3 hypotheses. Let me quickly say this. In some climes, in some schools, if you are going to publish in some journals, they will always tell you to use your a priori expectation to determine how you will state your hypothesis. You know, hypothesis can be stated in null form or in alternative form. But in Nigeria, since the bulk of our participants are Nigerians, we really have from the record, we have about 52 from other African countries, Southern America, Europe, and Asia. So, but over 900 of the participants are domiciled in Nigeria. So let's use Nigeria. So most schools in Nigeria will always tell you to state your hypothesis in a null form. But so many universities in UK will tell you, use your a priori expectation. A priori expectation has to do with, you know, your methodology. When you do your model specification, you state your a priori expectation, which is always informed by extant literature. Based on literature, what is literature saying? Is literature saying that motivation will lead to employee performance? So if that is what literature is saying, your hypothesis should be stated in the alternative form, which is the positive part. So non-hypotheses are always stated in the negative form, does not. Why alternative hypotheses are stated in the positive form is. So in this our case now, let's use what is applicable to most universities in Nigeria and most journal outlets in Nigeria. But take note of both. So now our first hypothesis is we're saying hypothesis 1. There is no significant association between increment in salary and employee performance. Hypothesis 2. There is no significant, or let me state it this way, bonus does not significantly affect employee performance. Hypothesis 3. Motivation elements do not have significant combined effect on employee performance. So we have the 3. So the first one, we're looking at the association between increment in salary and employee performance. Second one, we're looking at the effect of bonus on employee performance. The third one, we're looking at motivation elements, which are increment in salary and bonus, the combined effect on employee performance. So the first one, if you quickly recall what you were taught in your undergraduate days under statistics, you will agree with me that whenever you talk about association or the direction of a relationship, the most appropriate tool is correlation. But I have to quickly say this, that that is after you would have done your pre-estimation to ascertain if the data is normally distributed or not, that we should determine if you're using parametric or non-parametric tools. We're going to have a video on that. But in this case now, let us proceed. The most appropriate tool is correlation coefficient. So what we do is we analyze. So if you check the first, what you have here, the first is phi, second is edit, third is view, fourth is the fourth one. After view, you have data. After data, you have transform. So this is analyze. So all the tools you want to use for your analysis is there under analyze. So you click analyze, then the drop box, we go down, we look for correlation. So you can see correlate. So we decide if it is bivariate or partial. We're going to have another video for this to explain it. So let's say bivariate, we click bivariate. So you see the box that we have. So all our variables are here. So the first one, we're looking at the association between increment in salary and employee performance. So what do? We pick these two variables, increment in salary and employee performance, and correlate it, then get our result. Increment in salary is depicted by IS. So I click IS, then I use the arrow to send it to where we have variables. Then the next one is employee performance, EP. I click EP, then I use the arrow to send it to where we have variable. Then that is all. Assuming I want to add some other statistics, mean and all that, I can click statistics. You can see statistics here. So, but I don't need that. I only need the coloration. So I just click OK. So it has given me my result. So this is my result. This is the result. So from this result now, we just came up with an hypothetical example of a questionnaire, and we guess the responses of the respondents. If you recall what we did under the coding, so it's not a real live questionnaire where you gave it to people to fill. So this is the output now. So you can see where we have sync, SIG, that is your p-value. Your sync is your p-value, probability value. And if you recall what you were taught under statistics, it must be less than 0.05 for you to say it's significant. So if you look at what we have under sync now, we have 4.95. So that 4.95, which is 4.05, which is higher than 0.05. So meaning that there is no significant association between increment in salary and employee performance. And if you look at the correlation coefficient, you can easily deduce. See, this is what we have. Correlation coefficient. We have minus 0.535. So that is minus 0.535. So what you are having here is a negative relationship. However, the negative relationship is not significant. So there is no significant association, a negative association, but it is not significant. So this is correlation coefficient. So once you have your result, you interpret. Two things you have to take note of is the sign that appears before your coefficient like this. If there is no minus, it is automatically positive. Then the figure, then you now quickly look at the sync, SIG. So you look at the sync. If it is greater than 0.05, it is not significant. So you reject your null hypothesis. You accept your null hypothesis because it's not significant. But if it is less than 0.05, it is significant. So you reject your null hypothesis and accept your alternative hypothesis. Assuming what we have here now is 0.04. It is lesser than 0.05. So we'll reject the null hypothesis. So what it will be telling us is that there is a significant association between increment in salary and employee performance. So this is it. So I want this video to be relatively short. So we'll do another 10-15 minutes video for interpretation. So this is it. Then I now want to check my second hypothesis. Let me go to for my second hypothesis. So this is go back to the data. If you click that sigma sign, so I have these are my data. So my second hypothesis is that that bonus does not significantly affect employee performance. So whenever you hear affect, you should know that is regression. So the same thing, I go back to analyze. I click analyze. I look for regression. This is regression. So SPSS is now telling me that uncle, auntie, what kind of regression do you intend to use? Is it linear? Is it you can see polynomial? Is it binary logistics? Is it ordinal? So we're using linear. That is, we are assuming that this data conforms with the assumptions of OLS. So that is another video entirely. So linear, I click linear. So now I have my boss for the first boss is all my variables. You can see all my variables are there. Then I have a box for dependent variable and another one for independent variable. In SPSS, you can only have one dependent variable. So you can see they didn't pluralize it. However, you can have more than one independent variable. You'll see it with our third hypothesis. So now, from your work, you can easily spot your dependent or independent variable. So now, in our second hypothesis, now we're looking at bonus does not significantly affect employee performance. So employee performance is our dependent variable. So I will go down, check for employee performance. So once I see employee performance EP, I move it to dependent. Then our independent variable is bonus. So we depicted it with BN. So bonus, I move it to independent variable. So that is all. Then okay. The result will be out in less than 1 second. This is the result. So in this result now, you have done your regression. Once you've got to this point, you have done regression. This result now, the first table is telling you what you inputted. What you inputted is telling you that you can see that your dependent variable is EP, then BN is your independent variable. Then this from the second variable is what you want to utilize. Your model summary. What you need in this model summary is your R square. If you are dealing with a simple regression like what we did now, where you only have one dependent variable, one independent variable, that is what we call simple regression. So you use R square. But if you are dealing with multiple regression, like what we're going to do under the third hypothesis, where you have one dependent variable and two or more independent variable, you use the adjusted R square. So now under that model summary, this model summary, our R square is 0.26. So that is what our R square is giving us, 0.26. Now, that R square is also called coefficient of determination. It shows you the percentage of change in the dependent variable that is accounted for by the independent variable. It shows you the percentage of variation in the dependent variable that is accounted for by the independent variable. It shows you to what extent does the independent variable affect the dependent variable. So in this case now, we have 0.26, for example. It's telling us you multiply it by 100. So that is 26%. It's telling us that bonus accounts for 26% change in employee performance, while other factors not captured in this study account for the remaining. When you remove 26 from 100%, we have 74. Account for the remaining 74%. That is your R square. Then this ANOVA, what you need there is your F. You can see your F statistics, and the significant level. If this F statistics is significant, if it is significant, that is, if it is less than 0.05, it's telling you that your model is fit for prediction and decision making. Then if it is multiple regression, it's telling you that your model is fit for prediction and decision making, and at the same time that all those variables, all the independent variables that you use for your studies, they have combined effects on the dependent variable. So you can, if it is multiple regression, like when we get to our third hypothesis, we're going to use the F to determine if bonus and increment in salary has combined effect on employee performance. So in our case now, our F, the significance of our F is greater than 0.05. What we have is 0.3. Is it 0. No, it's 0. It's 0.03, which is lesser than. Is lesser than. What we have here now is lesser than. So we can say our model is fit for prediction and decision making, because it is simple regression. We're not doing multiple regression. Then we now go to the coefficient. The coefficient will tell us if that variable, the bonus, in this case now, bonus is a variable. If bonus has significant effects on employee performance or not. So let me quickly scroll down. So that is the last one, coefficient. This is the last one, coefficient. So now you check the T. of the coefficient. This is the T. This is our coefficient. You can see the constant, then you can see Bn. The constant is what you see as beta naught in your model. So this is the Bn. So you trace it. You can see it's even giving you the coefficient of the Bn. If you can see this unstandardized coefficient, the B is giving you negative sign, meaning that it is negative relationship. So we want to know if it is significant or not. So look at the sink. What we have here is 0.038. So which is 0.038, meaning that bonus has significant effects on employee performance. However, the effect is negative, meaning bonus has significant negative effects on employee performance. Do this yourself, you will get it. Then let's go to the third hypothesis, because I want this to be less than 20 minutes. The third hypothesis, I go back to my data. So you will recall that our third hypothesis, we're looking at the effect of motivation elements on employee performance. And what are the motivation elements in our study now? They are bonus and increment in salary. So the same thing, you go back to your analyze. This is analyze. You click analyze. Then I go to my regression, because we're talking about effect. I go to my regression. This is regression. So what kind of regression do I want to use? So let me use linear for the purpose of training. But in real life, you would have done your pre-estimation test to determine. So linear. So, I just use regression now. So those data will still be there. So I will move them back, click on them, use the arrow to send them back to where I have all these variables. So this variable is still there. I'll send it back. So now I'm looking at the effect of motivation element on employee performance, which are IS and BN, increment in salary and bonus. So now those are my independent variables. So my dependent variable is still EP. So I click EP here. You can see EP. Then I use this arrow to send it to the dependent boss. So my independent variables are IS. I click IS, increment in salary. I send it to the independent boss. Then the second one is BN. I click BN. I also send it to the independent boss. So with this, I have been able to insert my variables to the appropriate boss. My EP, which is employee performance, is in the dependent boss. My increment in salary and bonus are in the independent boss. So I can now run it. Okay. 1 second, the results is out. The same thing. The first one is telling me the data I inserted. You can see my dependent variable EP. My independent variable, you can see BN and IS. So now let us now look at you will record, I say whenever you are working on multiple regression, you use the adjusted R square. You see my adjusted R square. So you can see my adjusted R square. So that is 0.005. 0.005. So it's very low. So now, I now come to my ANOVA. My ANOVA is giving me my F. You can see my F. The significance is 0.1, which is insignificant. 0.1. 0.1 is greater than 0.05. So it's insignificant. So meaning that this one now has told me that my model is not fit for prediction and decision making, and the combination of bonus and increment in salary does not significantly affect employee performance. My adjusted R square of 0.005 is telling me this is even less than 1%. It's telling me that bonus and increment in salary only account for 0.5%. Is 0.5%, because you multiply it by 100 to give you 0.5%. Less than 1% in the change in employee performance, meaning it affects employee performance with less than 1%, which is very small, and that is why the F is not significant. So let us now check our coefficient table. The coefficient table is below, so let me check. They are most likely not going to be significant also. Yes, you can see from here. This is our coefficient table. So you can see we have the constant, we have IS, we have BN, IS, BN. So see the T. The first one, for the first one, is even negative. The first one is 0.26, The second one is 0.06. So the first one, 0.2, is greater than 0.06. The second one, that is for IS. Then the second one, meaning that when you combine both together, IS does not significantly affect employee performance. Increment in salary does not significantly affect employee performance. The second one is 0.62, which is also higher than 0.05. So meaning that when you combine both together, bonus does not also have any significant effect on employee performance. So this is exactly 20 minutes. So that is all that we need to know for now, considering the fact that we are talking about a beginner's class. So we're also going to come up with another video on reliability and the parametric and non-parametric, how to ascertain your OLS assumptions, how to run your data to ensure they conform with OLS assumption. So thank you for your time.